Hello guys, welcome to another section of Learning with Prep Class. I am Tutor Chima. So in today's section, we will continue with what we have been doing. We'll be solving WAEC past questions on chemistry for the year 2018. And in today's section, we are going to be solving questions 36 to 40 because in our previous video, we looked at questions 31 to 35. So those that saw the last video, I believe it was very helpful, it was very engaging, it was very entertaining. I believe you learned one or two things. I believe it helped you to be able to solve one or two calculations that you've been finding a little bit challenging. Just continue watching our video, continue to follow us on our videos, and I bet you that you will not regret it. Now students, before we proceed, do not forget to subscribe to our YouTube channel, like our videos, use our comment section for dropping one or two questions. When you look below there, you see a notification bell. Click on it and turn it on. Once your notification bell is turned on, you'll be the first to be notified whenever we have an educational content like this on our channel. Now that notification bell will help you to always, or it will act as a reminder, so it will help you to keep engaging in our videos and keep learning new things, and your progress in chemistry will improve in no time. Alright, you can also be kind enough to share our videos so that it's going to reach as much viewers as possible. Now let us look at, or let's go straight to the business of today, which is to solve WAEC Chemistry 2018 questions 36 to 40. 36 says, the change in the oxidation state of iron in the reaction represented by the equation below is the change in the oxidation state of iron in the reaction represented by the equation below is, now they've given us FeCl3 plus H2S to give you FeCl2 plus HCl plus S. So what's the change in oxidation state of iron from here to here? Now you should know that FeCl3 is iron 3 chloride. Once you see this word iron 3 chloride, it means that oxidation state of iron there is plus 3. It's as simple as that. Or you can use the formula can write FeCl3 equals 0, then oxidation state of chlorine is -1 with that, and the whole compound 0. With that you get oxidation state of iron. But just know that once you see this name, iron 2 chloride, iron 3 oxide, iron blah 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 blah, that kind of stuff. So that's 3, that word here 3 tells you the oxidation state of this first element, which is the metal. So here iron 3 chloride, this 3 stands for the oxidation state of iron, and it is plus 3 because iron is a metal. So I said that FeCl3 is iron 3 chloride, and the oxidation state of iron is plus 3. FeCl2 is iron 2 chloride, so from this 2 here, the oxidation state of iron there is plus 2. So you can see that here it is plus 3, here it is plus 2, and that should be a reduction of oxidation number. So there's a drop in oxidation number from plus 3 to plus 2. So I now said that therefore the oxidation state of iron changed from plus 3 in FeCl3 to plus 2 in FeCl2. So the answer is it changed from plus 3 to plus 2. From plus 3 to plus 2. Very simple, very direct, very interesting. From plus 3 to plus 2. Now let us look at question number 37. Which of the following method can be used to separate blood cells from plasma? This is a very simple question. I believe you should know that the answer is centrifugation. So centrifugation is used to separate blood cell from what? Plasma. So I say that centrifugation is a separating technique used to separate blood cells from plasma. Now, in centrifugation, it involves using a centrifuge, which is a machine. You can see here they'll place the test tubes. Now they'll collect a blood sample, put it in a test tube. Then inside that centrifugation, that machine, there's usually a space to occupy like 4 test tubes. So they can get 3 more test tubes and fill it with the same volume of water. Are you following? Of that blood, then place it in those other spaces. Then place that other test tube containing the blood sample, so that there will be a balancing weight. Then they'll just press a button. Then the centrifuge will start spinning to spin for some time. That spin of the centrifuge forces the blood cell to go down, leaving the plasma of the blood to float up. You know, the blood is made up of 2 parts. Plasma, which is the liquid part of blood, and the blood cells, which is the white blood cell, red blood cell, platelets. Now, by spinning, or by this blood sample in that test tube, when it's being spun in that centrifugation, that action of the spinning forces the blood cell to go below down the test tube. So you can see here before, mixture of the blood cells and plasma scattered around. After spinning, what happened? That it now forces the blood cell to go down the test tube while the plasma flows up. So then they can easily remove the plasma and use the blood cell to do whatever they want to do. So the correct answer there is centrifugation. So centrifugation is used to separate blood cells from blood plasma. And I've explained how it is being done. So let's look at question number 38. Which of the following statements about ionic radius is correct? Which of the following statements about ionic radius is correct? Is it that ionic radius increases as nuclear charge increases? Is it that it decreases as nuclear charge increases? Is it that it decreases as nuclear charge decreases? Is it that it remains constant as the nuclear charge increases? Let us see. Now, I said that ionic radius is the distance between the nucleus of, is it the distance between the nucleus and the electron in the outermost shell of an ion? Sorry, I didn't draw I believe you know an atomic structure. Atom is made up of the central core, which is the nucleus, and the electron revolving around the atom in orbits. I believe you know it's very simple. You must have learned it in your SS1. The nucleus is at the center, which is made up of the proton and the neutron, and the electrons revolving around the nucleus. So now the distance between the nucleus and the electron in the outermost shell of an atom. You know, the electron or electrons in the outermost shell of an atom is called the valency electrons. Take note of that. The electrons in the outermost shell of an atom is known as the valency electron. Are you following? So that electron determines if that atom would be a cation, which is a metallic ion, or an anion, a non-metallic ion. Are you following? So the distance between the nucleus and the electron in the outermost shell is known as ionic radius. Now, I said that a higher nuclear charge, when the nucleus has a high nuclear charge, which simply means when the proton is much more electropositive, is positively charged. So a higher nuclear charge causes greater attractions to the electrons, pulling the electron cloud closer to the nucleus, which results in a smaller atomic radius. Hence, ionic radius is inversely proportional to the effective nuclear charge. So the higher the nuclear charge, the shorter will be the ionic radius. If the nuclear charge, the charge of that, the proton, is much more electropositive, is highly positive, has a high positive value. Are you following? If the nuclear charge is high, what happens? It pulls more of the electrons, even up to the one that is in the last orbit. It pulls it closer to that nucleus. You know that the nucleus, because of the proton, the nucleus is positively charged and the electron is negatively charged, and positive and negative charge attracts. So when the nuclear charge in that proton is high, it will pull the electron closer, and when it pulls the electrons closer, the distance will become shorter. So the higher the nuclear charge, the shorter will be the ionic or the atomic radius. Are you following? So I said that hence ionic radius is inversely proportional to the effective nuclear charge. The higher the nuclear charge, the shorter the ionic radius. The lower the nuclear charge, the longer the electron will move further away, the longer or the higher the ionic radius. So therefore, the ionic radius decreases as nuclear charge increases. So if ionic radius decreases, that means that the atom has a higher nuclear charge. So ionic radius decreases as nuclear charge increases. So which one goes there? Option B. So the ionic radius decreases as nuclear charge increases. Decreases as nuclear charge increases. So option B is the correct answer. 39. Analysis of the hydrocarbon shows that it contains 0.93 gram of carbon per gram of the compound. Now, the mole ratio of the carbon to the hydrogen in the compound is, so they're asking us to find the mole ratio of carbon to hydrogen in the compound. The mole ratio of carbon to hydrogen, and here they only gave us 0.93 gram of carbon per gram in the compound. So the mole ratio of carbon to hydrogen in the compound is, let us see. So analysis of the compound of a hydrocarbon shows that it contains 0.93 gram of carbon per gram of the compound. The mole ratio of carbon to the hydrogen in the compound is, let's see. So you can see carbon, hydrogen. Now, since the compound contains 0.93 gram of carbon per the hydrocarbon, so if we are taking the total mass of the hydrocarbon as 1 gram, 1 gram minus 0.93 gram will give us 0.07 gram. So if the compound contains 0.93 gram in every 1 gram of that hydrocarbon, it contains 0.93 gram of carbon. That means it's going to contain 1 minus 0.93 gram of hydrogen. So if carbon is 0.93 gram, hydrogen will be 0.07 gram. So this mole ratio they are asking us is just similar to asking us empirical formula. So that becomes 0.93 divided by 12, and hydrogen 0.7 divided by 1. So this divided by 12, which is the molar relative molecular mass or relative atomic mass of carbon, this divided by 12 will give us 0.0775. This divided by 1 equals 0.07. So divided by the smaller or smallest or smaller number, we have a smaller ratio. We have 0.0775 divided by 0.07. So this divided by this, and 0.07 divided by 0.07. So this will give us 1.0 something, which is approximately 1, and this will give us 1. So you can see that the ratio of carbon to hydrogen is 1:1. So the correct answer there is 1:1. A. 1:1. I believe you understand how we did this calculation to get this. 1:1 is the correct answer. 1:1. 40. The law of definite proportion states that is it that pure samples of the same compound contain the same elements combined the same proportion by mass? I think I've seen my answer. Is A, definitely. Is it that pure samples of substances are in proportion by mass? No. Chemical compounds are pure because it contains the same elements. No. Matter can neither be. This one is law of conservation of matter. Matter can neither be created nor be destroyed. That's law of conservation of matter. So now, law of definite proportion simply states that all pure samples of a particular chemical compound contain similar elements which are combined in the same proportion by mass. That's the law of definite proportion. And it's also known as the law of constant composition. So when they ask you state the law of definite proportion, it simply means state the law of constant composition. And it states that all pure samples of a particular chemical compound contain similar elements which are combined in the same proportion by mass. Now, looking at this statement, which of the options correctly give this? It is A. Pure samples of the same compound contain the same elements combined in the same proportion by mass. And because of that, the correct answer to this question is A. Pure samples of the same compound contain the same elements combined in the same proportion by mass. Alright guys, we've come to the end of today's section of Learning with Prep class, where we looked at past questions on WAEC Chemistry 2018. We solved 36 to 40. We've dropped a link for you here. Type this link on your browser. When you do so, it's going to take you to our WhatsApp group. Now when you join us on our WhatsApp group, you'll be getting updates, you'll be getting infos on the latest interesting educational video we have on our channels. I still remain Tutochima, and I believe I'll see you in the next video. Bye, and do stay safe.